Welcome. Today in this video I want to teach you the basics of math. I always thought about recording a video talking about the basic concept of math for someone who's struggling with math or want to remember the most basic and subjects in math that is very important if you were a high school student, even a college student. So first I want to talk about solving an equation. Okay, so we have something called the linear equation. Okay, something like, think about 2x plus 5 equals 17. So how I could find the value of x, for example, this is equal sign, means this side equals this side. So if I added minus 17 to both sides, I'm adding the same value on both sides, okay? So it would be 2x plus 5 minus 17 equals 17 minus 17. So I added minus 17 on both sides, okay? So that means 2x, okay, minus 12, I'm sorry, okay, because this is minus, equals 0. Okay. At the same time, what I'm gonna do now, I'm gonna add 12 for both sides. So 2x plus 12 minus 12 equals 12. So those cancel out together. So we will left over with 2x equals 12. Okay. So I'm gonna divide both sides on 2 by 2. So this will be divided by 2 and this will be divided by 2. 2 divided by 2 is x, which 12 divided by 2 is 6. So x equals 6. Now, how they usually explain it, let me tell you how they do it. Usually in school, why they don't focus on teaching students those basic skills. What they do when we're in school, middle school actually, not high school, they told you if you move a number for the other side, you change its sign. Okay, so you'd say like 2x. They'd say this is 17. Okay, we keep it. Then we move plus 5 to the other side, so it will be minus 5. Okay, so that gives us 12. Okay, 2x. Therefore, x equals 6. That is also true, but if you want to think logically, the right way to say it, that we add the same number for both sides, okay? So this basics makes the students understand the logic behind math, not just memorizing things, like memorizing steps, okay? No, we should teach him. Then when he's gonna solve, he say, all right, we're gonna move something for the other side and behind the equal sign, equality, we're gonna change its sign. But the actual explanation, the mathematical explanation that I already did, adding the same value for both sides. So the equal sign is still correct. Okay? So the same thing if I want to say, for example, 7 minus 3x plus 1. Okay? I could say, move this from here. 1, which would be 7 minus 1. I'm going to move this to the other side. I'm going to change its sign to 3x. So 6 equals 3x, therefore x equals 2. Okay? They call it a linear equation because x to the power of 1. So it's linear. And when we think about when we draw a graph, a function like x plus 1 something, the x-axis, it would be something like this. Okay? So it's a line. It's a line. It's not like a U-shape, like a function from the second degree, from the second term, okay? Just like that. So let's move to another, I'm gonna erase everything. Another concept, system of equations. When I have two equations and I wanna find the value of x and y, okay? X, for example, plus y equals 10. This is the first equation. The second equation, x minus 4, x minus 1 equals 4. Okay? So you have to understand something. In math, when we have two equations, two unknowns, how many unknowns I have here? I have two, which they're x and y. How many equations I have? I have two. So two equations, two unknowns, I could solve the system. If I have, for example, only one equation, let's say x plus 1 equals z. What is the value of z or x? I can't know. I don't know. Because I have two unknowns and I have one equation. I need another equation. Let's say, for example, z plus x equals 5. Now I could solve it because I have two equations with two unknowns. So if you want to solve the system, and what we mean by solving the system, finding the value of all unknowns in the system, okay? So I want to solve this. I have a lot of ways. Actually, I could add those two equations together or subtract those two equations together. The first equation from the second or the second from the first, it doesn't matter, okay? But you think about something smart. For example, I have here y and I have here minus y. So add them together, I will get rid of the y's, right? So I'm going to add this equation to this equation. I'm going to add this side to this side. I'm going to add this side to this side, okay? So I will say x plus y, this is the first equation, plus x minus y as it is, okay, equals 10 plus 4, okay? So it's 14 from this side. This side I have 2x. X and x. How many x? I have 2 x's, okay? I have y and minus y. How many? I have 0 i's. 0 i's means 0, okay? Like if I have 1 and minus 1, it would be 0. Therefore, x equals 7. Okay? Now, I know the value of x. I could plug this in an equation, the first equation or the second equation. I could say 7 plus y equals 10. Therefore, y equals 3. Okay? So, I was able to find the values of x and y. This is, I solved the system. This system, okay? This is what we mean by solving the system. That is very also important. Now, I want to talk about roots, okay? What do we mean by a root? Okay, how we deal with numbers, the power of something. Let's say I have, the rule is simple, a to the power of m times a to the power of n, okay? So we say a to the power of m plus n. For example, I have the same number, notice. For example, I have 7 to the power of 9 times 7 to the power of 1. It is actually 7, it equals to 7 to the power of 10. Okay? Because I have the same number. This is a rule you have to remember. Very, very important in math. Something else. If I have a to the power of m divided by a to the power of n. What's the solution? It would be a to the power of m minus n. For example, a to the power of 3 divided by a to the power of 1 equals to a to the power of 3 minus 1, which is a to the power of 2. Okay? Another one which is very important. Those are very, very basics of math. Everybody deal with math should remember them. A, for example, to the power of n, and all to the power of n. So, the equals a to the power of m times n. Okay? So, 10 to the power of 2, and all to the power of 2. So, equals 10 to the power of 2 times 2, which is 10 to the power of 4. Okay? I hope that was clear. So let's now talk about functions. Functions, okay? What is a function? You can think about it like a machine. You have a number, and the output is also a number. But this number was changed based on how the function looks like. How the function looks like, okay? So we say f to the x, fx. for example, 3x plus 2, meaning the relationship between fx, which is y, and this term, that y, if I have x, I want to see the value of y, let's say x is 1. So I multiply it by 3, then I add 2. Okay? Good? Now this is the value of y. So if I want to write like I have here an endless, this is x and this is y. Okay? When x is 4, I plug in 3 times 4 plus 2, which is 14. Okay? Now when x was 1, for example, I plug in 1. So I have 3 times 2 plus 2, which is 5. Okay? When if y was 0, for example, x equals, so 3x plus 2 equals 0, because I said y was 0. Therefore, x equals to 3x minus 2, so minus 2 over 3. This is the value that makes 0 equals to 0, y equals to 0. Okay? Now let's move to derivative. For derivatives, what is a derivative? Okay? Derivatives. Okay? What is it? Think about it. Usually people just memorize the rule. It's something like x to the power of n equals to, they say that it's n times x to the power of n minus 1. So what is the derivative of x to the power of 9? What is the derivative of it? Okay? Which is simply, they write it down as, alright, which is they say x to the power of 9, okay, dot, or slash, or whatever you want. So it means the first derivative equals to 9 times x to the power of 8. Okay? If I want to take the derivative of this as well, which is 9 times 8 to the power of 7. Okay? And so on and so on. So I could do that. What is the derivative of any constant number is always 0. So 5 prime equals 0. Million prime means the derivative of a constant number is always 0. Okay? So this is their derivative, first derivative. When they say like they put 2 primes on something, like what is the 5x 2 primes? You calculate the first prime, I mean x to the power of 5. You calculate the first prime, which is 5x to the power of 4. Then you calculate the second prime. This is the first prime. The second prime, you say 5 to the times 4 x to the power of 3. Okay? So now also when I talk about geometry here, I'm going to try and talk about anything that comes across my mind. Geometry, for example. Okay? Well, what is the area of rectangular? This is a rectangular. Okay? It has the length L and W. Okay? So the area is this. The area of a rectangular is L times W. Okay? Of a triangle, what's the area of triangle? Okay? Which is the base. This is the base. And this is the height. So it is half the base times height. Okay? Good. Also, a circle. This is circle. What is the circumference of a circle? This is r. So the circumference of the circle is 2 pi, which is 3.14 times r. Okay? The circumference, which is the length here. Okay? It's not the same as the area. The area of a circle means that it's pi times r square. Okay, this is the area of a circle. Means this all the size here in feet square or in meter square, whatever. Okay, how cool is that? Also, I want to talk about, let's say, so for example, a phone costs $300. After 20% discount, what is the original price? So after a 20% discount, the price of a phone was $300. What is the original price of a phone before the discount? Okay? So what I'm supposed to say, I know that, let's say X is the original price times 0.8. Okay? So, therefore, equals, what's the price he was giving me? $300. So, X equals 300 divided by 0.8, which is, if you calculate it, 375. Okay? This also, especially for MBA students, we see this a lot. So hopefully this is the video. This is the first video I talked about math. Of course, there's a lot of things like I want to talk about in the future, but maybe integrals in the next video, God willing. Integrals also, inequalities, stuff like this probably in the second video. But hopefully it was useful, and goodbye.